detection. And fourth one that I am going to show you, that is a non-clinical scheme to actually assessment of blood malignancy, that is blood cancer, using a MEMS capacitive type sensor. Okay. So this is our motto, that instead of going to a pathological lab, that is not possible to the block level hospitals, we are making a lab on a chip, this type of device carrying a voltage control oscillator, MEMS sensor, then capacitance to voltage converter, and there is a display with a 1 micro drop of blood. If this display colors change, when the colors change, I will tell you. It is a scanning type of device. So with a micro drop of blood, this type of output will get. If all the cells are malignant, then this display color will be red. If few cells here, if it is present here to here, means few cells are normal and few cells are malignant, then it is orange. And if all cells are normal, then it is green. So it is a basically screening device in block level hospitals. Then we know different types of blood cancer, leukemia, lymphoma, etc. So this is the background study. Normally, blood cancer is detected by biopsy, that is by detecting the change in biological parameter, means they are actually sensing shape and size of the cell, thickness, diameter, etc. So a significant difference actually comes after a certain period of time. But here our innovation is that instead of biological parameter, we are actually trying to detect the electrical parameter, that is the dielectrical permittivity of the cell, conductivity of the cell, impedance of the cell. So significant changes comes in the initial stage. So early detection can be possible by this method. Then we did the frequency study and all these things. Last 2 works got the BIRAC Shishti Appreciation Award. We have a MOU with the Semiconductor Labistro, from where we made there are 100 sensors here in the small place. You see the size of the sensors compared to 2 rupees Indian coin. And with 1 micro drop of blood, see the changes of impedance. And if you go through our paper, there's malignancy detection, anomaly detection of the data by ANN, that is published in IEEE Transactions of Instrumentation and Measurement. If you are willing to see how ANN is worked for anomaly detection, you can read that paper. Then while we are doing this survey of this work, we came to know from the block level hospital that I think all of you know CBC count, that is complete blood cell count. CBC count is done by a device. It is called hematology analyzer. So for a normal, ordinary blood cell count, people from villages have to come nearby town or city for a blood cell count. So we are actually trying to develop a device by using this dielectrophoresis, through which there is a change so that the RBC, WBC and platelets can be identified or counted. So this is our objective, CBC test on a kit, first detection of anemia, malaria, leukemia, etc. It will be portable, affordable, and no prerequisite knowledge is required to use this instrument. So we know that actually complete blood cell count is very, very important, because it predicts, doctor can predict different types of diseases from the blood cell count. So this is the simulation of the device. These are the WBCs at the highest size or the highest diameters, then RBCs, and this is platelets. These are the counters, that is counting. And this is the size of the device, which is 1.5 cross 1.5 centimeters square. And Raja Ramanna Center for Advanced Technology Indore has helped us to make the device fabricated in real time. During COVID period, we didn't go. We are not actually able to go to neither Astrolab or RRCAT. So we have shifted from silicon to paper. These are the paper sensors we have developed. through which we can monitor the respiration rate of a human being while using a mask. It is inserted inside the mask and it is a paper sensor, so easy and watertight, biodegradable, no problem hazards. Now I will show you some prototypes that we have developed in our lab. I think another 15 minutes are having, madam. Hello? Hello? Hello?
Yes, ma'am, you have.
I am having another 15 minutes, na?
Yes, ma'am.
Okay. So now I will show you few prototypes that we have developed in our lab. As you know, we are a private organization, so cost is a factor for us. That's why I have recruited here, low cost. So our budget is less. So these all are low cost prototypes that we have developed. So first one is the electrical impedance tomography. I think you have heard CT scan. CT scan is computed tomography. The problem of CT scan is there are a few scanner, X-ray scanners are actually used in CT scan, so they are not harmful for human being. They are actually harmful for human beings. So doctor always suggests that there must be 6 months gap between 2 consecutive CT scans. I think all of you are not aware of tomography. What is the meaning of tomography? Though X-rays and tomography is cost, we all know X-rays are less costly and tomography, CT scan is very, very costly. In X-ray is a two-dimensional thing. If there is a tumor or anything stone, then we can find out through X-rays. But what is the size of the tumor? What is the shape of the tumor? All these things we can know through tomography. Tomography is a three-dimensional thing of X-ray. That's why it is costly. So we are trying to give a solution of CT scan. It is very costly as well as it is harmful for human body. So we have developed electrical impedance tomography by using some sensors. Excuse me. That is again getting the same pictorial view of our inner body, just like CT scan. And here we are monitoring lungs air movement during COVID period, because that time we are very much conscious about our lungs. We are having lots of paper on it. If you are interested, you can search and you will get it. Then in COVID, we heard about mechanical ventilator. Ventilator is a device, artificially we can make our breath alive, like that of thing. If there is a breathlessness type of thing, that time we can use a mechanical ventilator. And when we are using it at home, it is a form of CPAP. CPAP full form is that continuous positive airway respirator type of device. So it is a handy device. You can use it in your bedside whenever there is a breathlessness. It will start working. It will actually grab or fetch air from outside and forcefully it will inject inside your body. So again, we know what is a respirator. Respirator is a breathing device to sustaining long-term artificial respiration, and this is the normal breathing rate of human being. This, if it comes down, that is called brodypnea. If it is goes above, it is called tachypnea. So these are the abnormal things. This is the block diagram of our device. We have employed here BLDC motor, brushless DC motor. One of our research area is instrumentation for sensorless drive of brushless DC motor, because if you go through the dialysis machine or other medical devices, instead of normal motor, everywhere brushless DC motor is used. And these days, and the most challenging thing in brushless DC motor is that it doesn't have brush, so commutation is performed by using external electronic circuitry. That is the main interesting thing. So longevity of the motors are much higher. They are very lightweight, can rotate in high RPM. So there are lots of advantages. And this is our scheme that the person who is having some breathing trouble can wear a mask, and the MEM sensor that I have shown you earlier, that is actually connected in the mask in such a way that it can measure your respiration rate through your breathing. When you are breathe out, the pressure sensor will sense how many times it is breathing out per minute, and such if abnormality occurs for more than 2 minutes, then it will start the blower on and the air will come from the outside. So this is the device we have developed. Here the BLDC motor we have taken from a scrapped PC hard drive. There is a BLDC motor, and these are the electronic equipment, not more than 250 rupees. So our student made this, and we have a patent on it. And this is the proposed scheme. And it is a self-calibratory type of instruments, because it's having the AI inside, so that we can easily know, we know that the respiration rate or the respiration pattern of human being varies with years. So this is the normal breathing pattern of human being while child, while adult, and while old. And this is the abnormal breathing pattern. When a person is wearing it, it can easily identify the age group of the person, and according to that, it may function. That is the self-calibratory of the device. So as a guide, me and my MTech student got the award from Kochi DRDO lab from our own IISc professor, Professor Kupanidhi. And then I am going to show you wearable activity monitoring device. You may think that these days everyone is wearing Mi Band or other bands, Motorola band and all bands, to know our activity monitor, to how much we are walking, how many steps we are counting, calorie burning, etc., etc. But our target is to know the condition, physical condition of our aged parents or grandparents who are staying far away from us by giving a monitoring device like this. So the person who is willing to monitor can get this type of output, that while there are 3-axis accelerometer, MEMS accelerometer we are using when the person is sitting or sleeping, when person is walking, and when person is running. Similarly, we can get this type of device to a child while they are in creche or school. Maybe working mothers are willing to know what our child is doing, and it is a low cost, and the main attribute is that it is a standalone device. It does not require any smartphone to use it. Normally, the marketly available Motorola band or Xiaomi band, Google Fit, everywhere a separate smartphone is required to run the algo. But here we are not using any smartphone. The device, within the device, microcontroller itself is working. So at the final stage, we compared our device with the other marketly available devices and found a very good results. Again, it was published in IEEE Transaction. If you are interested, you can go through. I think it will give you the idea what type of algo we have written. So this device is standalone, does not require any external device like PC or smartphone, and energy efficient. So by using AI within it, we can intelligently predict that how much steps he has taken or how much calorie he has burned, and other data also we can take in. The last thing that I'm going to show you is the smartphone. You see here that the person is suffering from Parkinson's disease, And in case of such a disease, there is unwanted hand tremors. So the person is facing trouble while having food, while having medicine, while serving food, or in other activities of his daily life. Excuse me. So this is this Parkinson spoon that we have developed, not spoon, we have made the platform through which you can fit in any spoon. And the existing solution for Parkinson disease patient is the heavy weighted capillaries, so that they can stabilize soon. But the problem is that a person having unwanted hand tremors, he or she can carry such a heavy weighted thing always, is again problematic. So our approach is that we have taken a MEMS accelerometer inside it and servo motors, so that first few seconds when you are giving this spoon to a Parkinson disease patient, it will actually calculate the tremors of the person itself. Then it starts working. It gets it again actually creates its own tremor opposite to the tremor of the hand, so that the spoon gets stabilized. And this is the attributes of the smart spoon. That the Google is having a Parkinson disease patient smart spoon, but that cannot be washable. But our spoon can be separated from the circuit. It can be washable. It is battery operated, so no harm. And then the software and hardware we have used all are open source, so anybody can develop it and use it. So not only IoT based, we did with the AI also, that from the hand tremors, if we get the data from this accelerometer, we can easily know that at which frequencies the hand tremors is going on with medicine. We can predict whether the hand tremors are coming down or not with the help of the sensors. And then we can change the medicine like that. Predictive medical data analysis, that also we can do from the doctor's end. And finally, we got Gandhi and Yan Technological Innovation Award at Rashtrapati Bhavan. Me and my students are standing there. We got it. And thank you. I think I have completed in time, madam. Any queries? Hello?
Yes, madam.
Ma'am, I have some question actually. Yes, I have a query, ma'am. Ma'am,
Yes.
if anyone wants to work for the first time on the IoT devices, then what should be the approach he or she should follow?
IoT devices.
Yes, or that
IoT,
device actually phone,
IoT is having
already
4
used in the
layers.
devices, sensors.
Yes. If you know the IoT is having 4 tier system. Okay. First tier is the sensors, that is the physical layer or sensors. So in case of IoT, the sensors plays a very important role, because the data that we are gathering from the physical world, that is through sensors. So sensors are very specific. Sometimes people are doing wrong while they are taking choosing of sensor is wrong. Then what is happening, instead of carbon monoxide, it is sensing carbon dioxide, carbon monoxide, etc., etc. So the sensitivity of the sensor should be very, very high. And second one is the communication thing that I told, it will communicate. And third one, you have to do the upload in the cloud. And fourth one is the cloud computing or something. So if you go through the architecture of the IoT, you have to know the protocols, the sensors, how to connect it, how to upload the data of the sensors through some Arduino or some other type of microcontroller to cloud. These things, if you know, then you can easily do it. And these days, lots of these YouTube videos are also there, through which you can do very short type of this clippings are there, how to do it and all. Then you can do. That will helpful for you. And there are Coursera, there are lots of courses on IoT, there are hands-on also. So if you start with small thing, that how to, suppose we are measuring temperature. I have a coffee mug here. I want to know what is the temperature of this coffee mug. Okay. So I can put here a micro sensor or whatever semiconductor sensor, and then I can upload the data in the cloud, and that we can monitor through our phone. That is a very small example of IoT that you can start with that. I think it will help you. Okay,
Okay, thank you, ma'am. Thank you very much.
most welcome.
Do anyone have any other question to ma'am? You can ask.
Everybody understood what I was trying to say?
Actually, it was a very good session. Actually, I have first came to know about different sensors. Actually, I never knew that this sensor already existed. So this is
Yes,
very interesting for me actually.
yes.
So thank you, ma'am, for providing this kind of lecture.
Thank you, thank you. Anyone else?
So ma'am, shall we conclude our session?
Okay, thank you so much.
Thank you
So,
so much ma'am for giving the link
now,
of the session. Okay, ma'am. So we are concluding our session for today's first half. We will be joining the next session, which is on 12 noon, which is at 12 noon today itself. After a short break, we will be resuming our session and we will be sharing the Google Meet link in the WhatsApp group. Please join whenever you are free. Thank you.
have a nice day, and if you have any query, I have shown you my mail ID. You can write me always. Okay, thank you.
Thank you, ma'am.
Thanks
Thank
for
you
the
very
question.
much. Thank you very much, ma'am.
Okay, thank you. I'm leaving.